All right, so let's look at question 6. So for question 6, it's all about stations. So each node that you see in this tree right here is representing a station object. So what is a station object? It comes from this class where it has a name corresponding to the name of the station, travel time, which is the travel time from the Berkeley station. The Berkeley station is actually the root of this tree. Doesn't seem very obvious, but notice that there's nothing coming into Berkeley, which makes it the root. And then it has a linked list of its children, also has a constructor. Okay, so for part A, this is important. If you want to build a tree of stations, right, where we order them by their travel time, then the expected result would be first Berkeley, because it has a travel time of 0, since we're starting at Berkeley, and then MacArthur, and then El Cerrito, and et cetera, based on their numeric values, right? So for part A, we want to implement this comparator interface, right? So the comparator interface takes in, well, it doesn't take in anything, but it has a generic type T, right? So it's a comparator T interface. We want to first determine what T is, and then we know that it has a compare method. And this compare method is already implement the criteria for determining of two station objects, which one is greater, which one is bigger than the other one. Okay, so remember that compare will return an integer. And so based on what the numeric comparison, or well, not necessarily numeric, but what the comparison, the customized comparison of two objects are. So if object 1 is less than object 2, it's going to return a negative integer. It's going to return a positive integer if object 1 is greater than object 2. And it's going to return 0 if object 1 is equal to. And let me just make sure to specify that this is dot equals O2, object 2. So let's actually look at the solution here, okay? So the station is going to be our type, right? We're dealing with station objects. And then we're going to be returning an integer. And then we're going to be comparing two station objects that are passed in explicitly. So remember that in the compare bool interface, we had a compare to method that took in only one object, right? Because we could call the compare to on an object, right? So we could say like this dot compare to and then whatever object we passed in. But this is different. Compare actually takes in two separate objects, and then it kind of serves as a third party determining which one is bigger than the other. And in this case, we care about the travel time of these objects, so we just return O1.travel time minus O2.travel time. And that is it for question 2. Oh, sorry, question A.